Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers. Welcome to the dynamic learning hub of ExcelR at Andheri East, a prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Okay, right. Good evening, everyone. Please confirm me if my voice is audible. You can confirm in the chat box. And also, please confirm if my screen is visible for you. Okay, right then. Right. Okay, thank you. So welcome back to the student development program on Internet of Things. So we are in the third day of our sessions. In the last couple of sessions, we discussed about what is an IoT, what are the different things about IoT we discussed in the last couple of sessions. And today's session also will discuss few more things uh, of IoT, like what are the advantages, disadvantages, what are the characteristics of an embedded systems, and we'll discuss few more topics. Again, I'll confirm you that for this and tomorrow session mostly will be the theoretical part because we need to learn about some foundation things. So without knowing this, we can't jump directly into the hardware sessions or more in deep. So after these theoretical sessions, we are completely focusing on the hardware and we'll do some practical sessions like how to collect the data, how to transfer the data, and that we'll discuss in our next session. Okay. So today, now in this particular session, we'll see some advantages and disadvantages of this particular IoT. And right, so first of all, we'll discuss about the advantages. In that, the first comes under the automation and control. Using this particular IoT technology, we can control and we can automate any devices for the efficiency. Okay, right. Like this IoT enables automation of this routine task, so which leads to the increased the efficiency and the productivity of that particular machines. And remote management, so they using this we can manage or we can control any devices remotely, which provide the convenience and also we can save some particular time, right? And also we see like in the key features of an IoT, that is also one advantage. The next one, which is nothing but the data collection and analysis. Okay, so right, using this particular technology, we can collect and transmit the real time data, which we can analyze, or which we can make some informed decisions on that particular devices. Okay, and also by connecting this, we can monitor the equipment, we can predict when the maintenance is needed, and we can expect the or we can reduce the downtime, and also we can reduce the repair costs. Okay, and also we can enhance the customer experience. Okay, using that using this particular IoT, we can provide the personalized experience by providing or by understanding the preferences and the behaviors. And also we can improve the service deliveries, like businesses which they can enhance the service delivering through IoT enabled devices, such as smart homes, appliances, wearable tech, like that. Even in that particular some things there, we are using drones. Okay, drones are there, which where we equipped with this IoT technology. With this particular technology, drones can be monitored. Okay, the delivery can be done using that particular drones. Okay, so we have this particular cost savings are also there, like using that energy efficiency. So this particular IoT can optimize energy usage in homes and industries. Okay, which leads to the significant cost savings. Okay, and the resource management is also there. The efficient resource management in agriculture or logistics and other sectors can reduce the waste and improve the productivity in that particular sector. So that in that sector we can save the cost and the revenue. And also one more major advantage by using this particular technology is the safety and the security. Okay, we can monitor, we discussed, that we can monitor this particular devices or the machineries, like which can enhance the security through surveillance systems, by alarm systems, and then real time monitoring is there. And moreover, we can also monitor our health using some wearable devices, which can monitor our health parameters, which can give some alert to the users, and also provide some potential issues can be there, which providers can about will learn about that particular potential issues. So these are the advantages of this particular IoT. Okay, and next we'll discuss some disadvantages also. Okay, right. Coming to this security and privacy concern, one thing is we have advantages also there. At the same time, we have disadvantages are also there. So the first one is data breaches. Okay, so these IoT devices can be vulnerable to hacking, leading to the potential data breaches and loss of the sensitive information. Okay, and also there will be a private privacy issues will be also there. So the extensive data collection by IoT devices can lead to concern about user privacy and the data misuses. And the next disadvantage is like the complexity and the integration. Okay. So these compatibility issues will be there. As we all know, the devices are from different manufacturer. Integrating these various IoT devices from different manufacturers will be a challenging. Why? Because I told you in the last session that we are a lack of standardizations. So because of that, compatibility issues will arise. And also there are some complex systems are there. So managing such large number of interconnected devices can be complex, and for that we require some sophisticated infrastructure. Okay, and cost is also there. Initially the investment is high, but after that setting up this IoT infrastructure will be expensive. But due to the cost of the devices, sensors, and network components, the initial investment will be more. And also the maintenance, your regular maintenance and updates are required to proper what we say to function that particular system properly. So that read some maintenance should be there for the devices. That is for that adding will be sorry, what we say, adding the cost to that particular devices. Okay, and the next one is about the reliability. So depending, it completely depends upon internet. As I know, this is the technology is the backbone of this particular in technology is about this internet. So we are more depending upon that particular internet. So IoT devices rely on that particular stable internet connection. Any disruptions can affect their functionalities, and the device failures is also one more things. So the IoT devices can malfunction and become uh, absolute, leading to the potential disruptions in the operations. So there is another one is like ethical concerns will be there, like surveillance. The nature of this IoT can lead to that particular ethical concerns about the constant surveillance and the potential of misuse, etc., etc. And then the job displacement. So automation and IoT can lead to job displacement in some certain sectors, raising concern about their employment and the social impact. Okay, so this is about the what we say disadvantages of this IoT. Okay, and these are the advantages and disadvantages of IoT. And next we'll move to the characteristics of an IoT. Okay, right. So in that, let us discuss these few aspects in this particular thing, starting with the connectivity, sensing and precision, dynamic and self-adaptability, self-configuring, interoperability. Like that, we'll discuss one by one in this. Okay. The first one is the connectivity, as we also discussed about this in the key features of IoT. So this connectivity, which is all explains about the interconnection of this particular IoT devices. So uninterrupted connection at any time, anywhere, and within any IoT devices. For example, connection of these IoT devices with the internet or connection with the gateways. So this is a very prominent one in the connectivity. And next is a sensing and precision. So these IoT devices are equipped with some sensors, actuators, which we call it as an embedded systems. So sensors are very important because to sense that particular physical entity, and actuators are also important to work to turn something on or to what do you say off, or to get that particular track that particular real-time data. We need this particular actuators. And then dynamic and self-adaptability. So this is one more concern, one more characteristic, adaptability to that particular changing constraint, operating the conditions, user context, and sensed environment. Again, surveillance system, it should be adaptable to that particular environment. Okay, and we have this self-configuring. It means the ability to change the operating parameters based on that particular ongoing situations. So they configure themselves with respect to that particular situation. And interoperable communication protocols are there. Like they support various communication protocols at different levels. So we need to adapt or interoperable for that particular um devices and protocols. So that is one more characteristics. So it is an unique identity will be there. So using that particular unique identity, we are going to control that particular devices. So because we have an IP address will be there, unique identity, unique identifier. Using that, each devices can be controlled effectively. And we have that IoT devices with some intelligent interfaces will be there, which are connected to that particular ecosystem. So this is one more uh, characteristic. And the heterogeneity will be there. Integrated of information network. Okay. And scalability, security, and privacy. These are the different characteristics. I'm not going to in deep for timing, automation, and control. That is an advantages of this. Okay, so these are the characteristics of this IoT. So next, I'll try to I just want to introduce this one more concept, which is nothing but M2M communication. I just introduce this particular concept. Okay, machine to machine. This machine to machine is very important because we call it as say suppose if AAC is there, we call that as a small machine. Okay, so say suppose there are some other fridge, we call it as a machine. Car, it is a machine. So this machine to machine communication is a little bit important. So let us work on this particular. Let us learn about this things. So this machine to machine here in this particular image is there, which is easily understandable. What is a machine to machine and what is the difference between this with an IoT? So this machine to machine, you can see the control panel is directly connected to this particular machine, either a car or a crane or a home or an AC or a fridge, etc., etc. But coming to this Internet of Things, this particular IoT, in between that we got this particular, what we say, uh, cloud comes into the picture. So everything is controlled or transferred to the control panel, or to the by exchange of data can be done through this particular cloud platform only. Okay, the data will be stored over there, and the data will be processed in this particular cloud platform. So that is the major difference between an machine to machine and an Internet of Things, nothing but IoT. Okay, so let us go dive into this particular M2M. What is in M2M is nothing but it is a machine to machine communication. So it provides direct communication between the individual machines or an individual devices. So it is designed to communicate between the devices or machine for a specific purpose. So if you want to control a, what we say, AC. Okay, we have a machine in our hand, which is nothing but the remote. That is also a device, nothing but a more machine. Okay, so here the data will be transferred from that particular remote to that AC controlling unit. So here the data is transferring, communicating with each other. Okay, right. So this IoT and machine to machine provides access to information without any human interaction. Whenever we use this particular IoT, so the information will be accessed without any human interaction. So this M2M uses non-IP based proprietary networks, but IoT uses of the broad network protocols. Okay, based on that particular IoT. That is the key differences between this IoT and M2M. Okay, so here the big picture of this particular M2M. Okay, so here there are some embedded nodes are there. Uh, Nodes are nothing but the devices. So all are connected with the network, and through that particular network, we have an gateways will be there. The gateways are uh, gateways is there, and through this particular gateway it will be connected to the data center or to the server using some wide or wireless communications. Okay, and the data center, from that particular center or that particular server, we are going to access that particular data. Okay. So here, let us discuss about this M2M gateway, the gateway. We all know about this gateway. We already discussed this. So it acts as an intermediate between the various devices and systems in this particular M2M setup. So, and these the gateways having the some functionalities will be there. So it should be have the connectivity between the machines and the data exchange between the machines. Uh, and the compatibility will be there between the different networks. Okay, so the main purpose of this particular gateway is between the network nodes communicate with each other and with the remote M2M area network. Okay, right. So I'm not going in deep in this. So I just want to show you one more thing. Just a second. Right. So this is a big one more big thing about this particular IoT. Let me focus on this particular concept. Okay, that's thing. So here, many of the people will think that this IoT is all about collecting the data and storing it in the cloud platform. Yes, that is a part of an IoT system, but it is not a full concept of IoT systems. Okay, so for that, let me explain you in that context. So here, you can see these are the sensors, actuators, and some other source of data for the data collections. Okay, just give me 1 second, guys. Sorry for the interruption. Okay, right. Fine. So here these are the sensors and actuators. So these sensors and actuators, so they are connected to one particular to a thing, or it should be a chair, it should be an animal, it should be a plant, or it should be some other. So this particular thing, which is nothing but an object, which will be equipped with these particular sensors. Okay, right. So which gathers that particular data and then transferred that particular data to that particular network. So there are some actuators are also there, which that allows that particular thing to act. For example, to switch on or switch off the particular light, to open or close a door, to increase or decrease that particular what we say motor rotation or the speed and like that. So these particular things are sensors and actuators. All these particular thing of data exchange or collection or working on that particular actuator includes that which can be used in buildings, vehicles, machineries, and all other equipments other escalator, gym equipments, etc., etc. So these sensors are not in all the cases or not physically attached to that particular things, but the sensor also are also maybe need to monitor. Okay, so what happens in that particular environment, or what happened to that particular thing, what is the temperature of that particular thing, etc., etc. So all these particular collected data will be shifted to the cloud platform using some gateways. We already know about these particular gateways, am I right? So these data which are coming from these particular things or the devices uh, goes to the particular cloud through this particular gateway. So this gateway it provides the connectivity between the things and the cloud part of this particular IoT. Okay, so this gateway will also have some data pre-processings will be done, filtering can be done before moving to the cloud platform. So here, why we need to do this particular what we say pre-processing or filter. So just I'll give you one example for an understanding why we need this pre-processing or filtering of data in this particular gateway. Okay. So guys, are you with me? Are you understanding what I'm saying? I forgot to ask you. Are you getting it? You can reply in the chat box. Yes, yes. Thank you. Thank you. Right. Fine. So let us discuss why we need to process or why need to uh, filter the data. Say suppose I installed let me take an example like say suppose my I have an in my hall, in my house, in my hall, I want to make my AC as an automated AC. Okay, depending upon the temperature. So my AC temperature should increase or decrease. Okay, what I did is, and that data should, I need to monitor that particular data. Okay, so at what time what is happening, say suppose in a classroom or in a seminar hall, etc., etc. Oh yeah. So for to monitor the temperature in that particular hall, what I do is I install some sensors, as you all know, because sensors are used to collect that particular data. So these particular sensors are installed at some corner. Depending upon that sensor functionality or the range, we use some number of sensors. Okay, for instance, let us think, take like 5 sensors or 6 sensors. I installed it that. So here I'm continuously, I may want to make it as an IoT system, so we need to push that particular data to the cloud platform. So here, so as you know, previously also in the last session we discussed about some agriculture. In the same way, what that sensors need to connect to some modules. The module will collect the data and push the data to the master devices. Okay, to that particular master device, I need to connect that particular AC, and that particular master device, the data will be connected to the cloud platform. Okay, we'll discuss till here. Okay, say suppose to monitor that particular temperature in my hall, what I need connected sensors, right? So that sensors data will continuously pushing the data from the slave module to the master module, and the master module will collect that particular data and push that particular data to the cloud platform. Okay, right? So here I made in such a way, right? For every say suppose 5 seconds, I'm push sensor data is collecting and pushing that particular data to the master device for every 5 seconds. Now imagine, for for first 5 seconds, how much data will be there? So as I used like 5 sensors, like 5 devices. So first 5 seconds, how many data will be collected by the master device? It's almost 5, right? You can now you can answer your things in the chat box. We'll do some calculations. Okay, 5 set of data. Very good. Fine. Thank you. Right. So after that, say suppose for 1 minute, how much data will be collected by the master devices for 1 minute? Come on, guys. Please do some calculations. You got it? What I said? 300 or 30 or 3000? Don't get confused at what I asked. Okay. So for every 5 seconds, I'm collecting them data. Am I right? So for one device, for 5 seconds, the data will be pushed to the master device. Like that, for 5 seconds, 5 values will be pushed to the master devices. Okay. And then what about for 1 minute? For 1 minute, 60 set of data. Come on, guys. Come on. I hope you are good in calculations. 300. Are you sure? 60. Some are making like 60. 5 seconds, one data. Okay, for 1 minute, let us discuss about like one device. For 1 minute, how many values will be there? 60 seconds divided by 5, 12. 12 into 5. How much? 1 minute, 60 set. No, 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 right? One not 1 minute, 60, right? 60 data, right? So for 1 minute, 60 values are storing in that particular master device for only 1 minute. Okay. But what about for 1 hour? For 1 hour, 60 into 60. Am I right? 60 day values into 60. How much? 3600. Right. Okay. For imagine for 1 day. How much? How much? 60 into 60 into 60. Yes, so there you can imagine, right? I don't want to stress you more. So you can imagine that huge amount of values are stored. So if you see an Excel sheet, say suppose the data will be stored, suppose we have an Excel sheet with different values. Say suppose if we have like 100 values, it is hard for us. Okay. If say suppose now you can imagine there are lots of data will be there. Okay, right. Here, what I'm using, all this particular data, I'm trying to push to the cloud platform. So, and one more thing, I won't use this particular data for only one day. I'll use this particular data for weeks, for months, for years together. So now imagine cloud is not like a, what do we say, storage device. Okay, if we keep on pushing the data to the cloud platform, one particular day, all our storage will be full. Am I right? So, and there are a lot of unused data or not unuseful data. So, before and also we need to think about from the cloud point of view also. Right. So, the cloud vendors, the service providers will charge us more. Why? Because if we are keep on pushing the data into that particular cloud platform, the storage will be full, and this particular cloud, the server service providers need to accommodate some what we say data. I mean storage space, right? So they need to procure more space. For that, they'll charge us. So what I do over here is these particular gateway, we are going to filter some data. We are going to do some minimum or a minimum analytics or minimum analysis. Say suppose for every 1 hour, calculate an average value and then push that to the cloud platform. Or do some other algorithms, use some other algorithms and push that particular data to cloud platform. So the burden on that particular cloud will be reduced, and we save lot of cost, and also we save lot of what we say uh, time on that particular cloud. So these gateways are used to process that particular data. That is what my intention to tell you. Okay, and also these particular gateways are used to transmit or exchange of the data commands from this particular cloud platform. In the previous examples, we told, right, the farmer is used to send a command like turn on the motor. That command, how he is sending, is not directly connecting to the gateway. Command is coming from the cloud. So the data will be used. So you can see there is a control data or a control panel. From that particular control panel, the data will be shifted to the cloud platform, and the cloud platform is shifting to the gateway and then to the activators. Okay, so this is a general usage of this particular gateway. And let's discuss this particular cloud gateway. As you all know, that is nothing but a cloud pan. So which we uses that data compression will be there. And also one, if you are familiar with the machine learning concepts or data analytics, if you are from that particular background, you know about this data compressions. Okay, so data transmission, data compression for the secured data transmissions between the field gateways onto this particular IoT servers. Okay, and also it assures the compatibility with various protocols and communicates with the field gateways using different protocols, and depending upon the what protocol it is supported by that particular gateways, that will be taken care of this particular cloud. And after that, what is happening here is there will be a data processor will be there. Okay, so this data processor will ensure the effective transition of input data to this particular data lake. Okay, and this control applications. So no data can be occasionally lost or corrupted. Okay, so here we have a data lake. If you are a big data, if you are working on a big data analysis, you know about this data lake. So data lake is nothing but it is used for the storing that particular data which are generated by that connected devices in a natural format. Okay, so big data will comes into this particular pictures or whether batches or streaming. So when the data is needed for a meaningful insight, it extracts from this particular data lake and then loaded to the what we say, this big data warehouse. Okay, you can see there are a lot of, say, suppose in the previous example, we use some sensors like temperature sensor, humidity sensor, soil moisture sensor, etc., XYZ sensors. So all data are will be in this particular data. We consolidate that, we classify that particular data in this particular warehouse. Okay, and after that we have data analytics will be there. Okay, so discuss about this warehouse. So this particular warehouse is used for the filtering and pre-processing the data which are needed for the meaningful insights, which is extracted from this particular data lake. And then, so this particular data warehouse will have a cleaned, structured or matched data when we compared with this particular data lake. So this data warehouse will store the contest information about the things, about the sensors which are installed, and the commands which are coming from that particular control panel. Everything can be stored in this particular warehouse. So here we have that all the data over here, and then we'll have this particular data analytics. Okay. So these data analytics are used, as you all know, the name itself says, um, to gain some actionable insights of that particular data. So, for example, the performance of the device, so which if identifies the inefficiency of that particular machines. Okay, some coloration, some patterns will be found. So, will to create some algorithms, all be that can be done in this particular analysis. And also, the from this particular warehouse, we can use some machine learning models. Okay, so which can predict some what we say, um, what is the predictive outcome of that. We can predict some data. Okay, so using that particular models, we'll send that to the control panel. Okay, from that control panel, we used to send some signals, applications to the actuators to alert them. Say suppose some there is a fire broke out in that particular house, so immediately the actuator will be activated, like the sprinklers will be activated. So the data will be stored in that particular cloud, and we can do some analysis later how that happened, etc., etc. So there are some user applications are also there, like this to the mobile phone, to the web application. We can also control that our sensors and what we say, devices using that applications. So this is a big picture. So I want to what we say, mention you that this IoT alone can't survive. So it completely depends upon some other what we say, technologies like this machine learning or some big data analytics. Okay, for like some other, what are the things, big data, AIs, machine learning models. So to uh, have that meaningful insights of that particular data. So for that purpose, we need the support of other technologies. So that's why I call this particular IoT, or generally we call this particular IoT as a technology integrator. So this particular IoT can integrate other technologies also. So that is what I mean to say about this. So is it clear, guys? Any queries in this particular slide? If you have any queries, you can ask me, guys. Is it clear? Okay, right. So someone is asking about to summarize that particular thing. So let me summarize this. Right. Fine. Uh, See, say suppose, okay, let me come from the beginning. So the sensors and actuators are the basic components, or the um, basic one where we need to collect some data, because data is more important. That is what the main agenda or these things. So data, using that particular data only, we are going to monitor, or we are going that particular data and this particular level. So right, sorry. Uh, Actuators are also there. So at this particular level, devices are there, sensors will collect that data and actuators will act accordingly. So to that, we can't directly, there is a two ways. We can connect these particular devices at this particular level directly to the cloud platform. That can be happened, but there is some if we directly push the data to the cloud platform, we already discussed that there is a shortage of storage will be there in that particular cloud. Okay, so to avoid that, there are some other complexities are also, to avoid that we use some gateways. So these gateways will filter that particular data, will process that particular data, and after processing and filtering, the devices will be pushed to the uh, cloud platform. Okay. So here in the cloud platform, the data will be sent, like there are other means are there. So which we can send that to a data lake, which is nothing but the big data. In that particular data lake, all the data will be stored, will be processed, and then that will be shifted to a warehouse for scrutinizing or classifying or sorting out that particular data. And from that particular data, the data will be shifted either to the machine learning models or to the data analytics. So data analytics is nothing but analyzing that particular data, how that data, how it is behaving, how the data will be processing. That can be done in this particular data analytics. And also we'll shift to the machine learning models. We'll create some models depending upon that particular data, and the models will predict that, like say suppose for a machines, it will predict the downtime of that particular machine, or else it will predict that maintenance. Okay, and that will be shifted back to this particular user. Okay, so user will monitor that particular data. Okay, right, that particular machine is not working properly. It may goes to downtime. Let's go and check that after the production cycle. So that can be predicted by this particular machine models. There will be a control panel. Using that control panel, you can control your devices, etc., etc. It might be a mobile application, or it might be some other X things. Okay, and also we can push some data from our web application or from our mobile to these particular warehouses also. Okay, or to that particular control panel. Okay, so there will be a control panel that will be control appliances that will recognize, and that will uh, what we say, the control panel will receive the data, and according to that particular data, it will be pushed to that particular devices. So this is a big picture of this particular IoT. Okay, so right, there are some other queries. Just let me uh, tell you. Just a second. Right, summarize. Okay, right. Someone is asking about big data. Okay, so big data is nothing but it is like in there will be like a structured or unstructured or semi-structured data will be there. So here the data which is collected by this particular sensors and are so huge and so complex. Am I right? So to process that, to store that, to analyze that, we use this particular big data. Okay, so which will be we use some structured format or some unstructured or semi-structured format we use to process that particular data. That is about the big data means. Okay, and someone is asking about um, edge computing and gateways. Okay, so generally, edge computing is nothing but it is the data will be processed locally. Okay, in local. Coming to this IoT gateway, this gateway will be acting as a bridge which collects the data from the devices and sends it to the cloud for processing. And it gateway will mainly focusing on the connectivity and edge data transfer. Coming to the edge computing, the processing will be done there itself. Okay, the gateway will be just acting as a bridge between the devices and the cloud platform. Okay, so that is an edge computing and gateway. right? Someone asked like warehouse. So as you know, the name itself says that warehouse, right? Um, right. So this warehouse, we know, right? Warehouse is all about storing all the different, what's say, goods in that particular place. So this warehouse is nothing but it is just like acting as a centralized systems to store that particular data in an organized manner, in an organized data for the analysis or reporting. So that is what is a warehouse is all about. Okay. Right, sir, can you explain how AI and IoT integrate together? Yes, say suppose here in the same example, say suppose data will be there. Suppose in the same example which I take like an hall. So this particular hall, the data will be the sensor data is keep on increasing. The values of that particular sensor is keep on increasing. So we need to predict that something is happened. The AI comes into the picture. What is an AI? Okay, artificial intelligence that will process that particular, okay, something is happened at this particular point, so we need to alert that, so self decisions can be taken on that particular aspect. So AI will come into that particular picture to take some immediate measures on that particular devices, on that particular systems. So here, so filtering here is see, filtering is nothing but it's not say suppose filtering in that side, removing all that below 50 values. I mean the value below 15 we need to filter, and we need to allow only above 50 values. It's not like that, that type of filtering. So here I told you one example. For every 5 seconds, okay, we are uploading some data. Okay, so there we need to process, or we need to do some filtering to reduce that particular data. So for every sorry, half second, or sorry, every half minute or 1 minute, we consolidate that particular data. Okay, before uploading. So why we need to do, I already explained, because the data on that particular cloud will be more. So for that we need to decrease that particular data to store. Even though the data, say as we already discussed, there are huge data will be there in one day. There are almost 80,000 values or 90,000 values will be there. So if we completely store on that, it will hard for any algorithm or any data to scrutinize or to process that. For that particular purpose, what we do is we filter that particular data, we consolidate that particular data, we'll do some algorithms, and then we push that data. Instead of storing that 8,000 or 9,000 values in the cloud platform, we'll store at least, will decrease, and we'll store at least 40,000 to 50,000 values. So that is what the filtering is all about. Okay. So here models are nothing but the machine learning models, guys. Machine learning models. In that, if we are creating any thing, that model will be there. That is what the machine learning models is all about. Okay. Right. So here we are not doing any projects over here, but I'll try to give you some insights. So how to develop that particular project. So we'll discuss that. What we say, different sensors and actuators and other things. How to do that? That we can discuss that. Right. So right. So let us move for some other thing. Just give me 1 second. And right. So here, based on all this, I just want to show you a video, okay, for a better understanding. Okay, just a small video, guys. Try to understand. This is a small video. You can understand. This is about a home automation. Okay, just a second. I need to share that volume. All right. So this is a small video. Watch this. Right. I hope you understood about this uh, thing. So this is a home automation example. Okay, right. So now you have a clear clarity of how this particular IoT works in a real time situations. Okay. So next, I'll try to introduce a new one, which is nothing but the architecture of this particular IoT. Okay, this is a little bit important. Okay, just a second. Fine. So the architecture of an IoT. Okay, fine. So first of all, we need to know why we need this IoT architecture. All right. So here, as we all know that there are various very complex systems are there. So which we need to connect that. We call that as so there are some multiple technologies are there with multiple devices are there. There are various sensors, network technologies, cloud technologies. So for this overall things, we need to have an architecture. Okay. So here the essence of this particular architecture is how the data is transported, how it is collected, how it is analyzed, how ultimated actually upon that particular things. Okay. So right. So for that, so this architecture will define the standards and the techniques for designing or building an IoT ecosystems. Okay. And these architecture standards and frameworks have emerged to address the challenging of designing this massive scale of this particular IoT network. So here there are some designing principles we need to consider. One is we need to consider for an ideal IoT architecture. So a layered approach is needed to be considered. So layered approach is nothing but which is independent to each other, but to reduce the design complexity and to flexibly implement that particular concepts or networks in that particular ecosystems. Okay. So here this IoT organized as a stack of different layers will be there. Stack of constrained devices, stack of gateways, stack of IoT devices. So constrained devices are nothing but the end nodes with sensors or actuators which can handle a specific application purpose. So they are usually connected to a gateway like devices. Okay, gateway which are like devices, low power, noisy network, commodities, communities, etc. with some IoT cloud platform. So typically they communicate via low power wireless protocols like a Bluetooth or a Wi-Fi, etc., etc. Right. So, but no matter the use case or the number of layers, so these are the key building blocks of an IoT structure. So these building blocks are always the same. Okay. So the first one is the smart things and network of devices, or we call that as a smart things. Okay. Um, just a second. All right. Sorry. Network and the gateways. Okay. So which these gateways are networks which will be enabling the low power devices. Okay. So before entering it to that particular cloud platforms or internet, so we have a middleware which is nothing but we call that as a cloud platform or IoT platforms, which are providing the data storage spaces which are advanced in that particular computing engines will be there with some analytical capabilities, etc. Right. And also we have applications that will be the final layer, which allows the end users to benefit from that particular IoT and also to manipulate the physical world. So these are the basic key building blocks of this particular IoT. Okay. So here there are different layers of IoT architectures are there. Okay, so there are some three-layer architectures like middleware based architecture, service oriented architectures, 5 layer, 7 layer. So let us discuss few prominent layers architectures. So I'll in this particular session I'll discuss a 3-layer architecture, 4-layer, 5-layer, and a 7-layer architecture. Okay, fine. So one thing you need to remember, the crucial thing to know about this particular IoT architectures is right. There is no uh, all solutions at one particular point for any project. Okay, so it all depends upon the requirement or the applications. So the complexity is completely depending upon that particular applications, depending upon the tasks which are connected to that particular devices, and how we are going to tackle that particular device, etc. So therefore it is important to know about all the IoT architectures layer to create a system which we meet the all the requirements. Okay, so even though almost all IoT systems are unique, okay, deployment is unique, so its architectures will be limited by some particular layers. Okay, so keeping that in mind, so let us move on to that first architecture, which is nothing but a 3-layer architecture. So this is the basic IoT layer architecture, so which are widely in used for a smaller applications. So this can be utilized because it is easy to implement. So, and also, of course, there are a lot of what we say drawbacks are there in this particular. The main concern is about the security threats. That is the most important reason why this architecture is not used in these particular days. But in generally, some applications we use this particular 3-layer architecture. So let us dive into that each and one particular layer. Okay, so the first one is about the perspection. Okay, so it is the foremost layer. Okay, we also call this as a sensor layer. Okay, so it implies that all the sensors that are used in this particular IoT devices will be in this particular layer. So then they will transform the signals from the environment and into some digital information, etc. And the sensors can help to create some maintenance system, etc., etc. There are some most popular ones are there, temperature sensor, humidity sensor, level sensor, infrared sensor, etc., etc. Okay, and then coming to the next one is nothing but the network layer. Okay, so it is also known as a gateway layer. Also, as you all know from the last two classes, we are discussing about this gateway, the same stuff. So here, so this gateway layer will establish the logical design of that particular IoT by connecting the devices to the platforms. Okay, IoT platforms. So the data will be captured by sensors, and that will be transmitted either by wires or wireless to that particular up cloud servers or to the servers. Okay, so the transfer data need to be secured to prevent unauthorized access. But in this particular case, we are not using that particular, in this particular architecture, we are not using that particular secured option. Okay, so here the most popular IoT communications models will come into this particular pictures, like Ethernet, Wi-Fi, NFC, Bluetooth, etc., etc. Okay, there are some other means are also there. We'll try to discuss that in the next slides. Okay, and on the top we have this application layer. So what is this application layer in this particular architecture? It is nothing but it is the final layer in any IoT reference model. So it represents all the devices that use these devices or the systems will be displayed in this particular applications. It can be a smart device that helps your house clean and safe, or it might be a smart home systems that can be managed with the help of a smartphone, whatever. Okay, so all this comes under this particular application layer. And also in each layer, there are some security threats are there. So like in this perspection layer, there is a security threat like what we say, timing attack, like node captures, so eavesdropping. So, and from the coming to the network layer, there are some man in the middle attack, storage attack, explosive attacks will be there. And here in the application layer, we have like a cross-site scripting, some code attacks, everything will be there on this particulars. We are not going in deep about that particular attacks, which will leads us out of the box. So this is about the three-layer architecture. And coming to this four-layer architecture. What are the four layers of this particular architecture are nothing but it uses the basic IoT, what we say, similar to the basic one, which is nothing but a three-layer architecture. So here the data will be collected by the sensors and transferred to the storage system by the network layer. And however, this particular architecture has one additional layer will be there. So this additional layer is nothing but the support layer. Okay. So this support layer will helps to resolve the main issue of this particular architecture, which we discussed in the third layer. So that is what is nothing but the security. So this support layer will give you that particular security feature for this particular data. So this support layer is placed between this remote network layer and this application layer. Okay. So the support layer will okay, as we discussed, there are a lot of threads are there, right? So in the three-layer architecture, okay. So this particular support layer will give you that particular security things, because it mainly focus on different communication models, so different possible threats are there. So these particular support layer will give you that authentication. Only the authorized user or authenticator user only need to use this particular. We have some passwords, we use some shared keys will be there, right, read key or the write key. Okay. So after that particular keys verified user, the supports layer will send that information of this particular sensors layer to that particular user. Okay. So this is about that particular security. So coming to this four layer, so we are adding a support layer in between for this particular three layer architecture. So the support layer will be in between this application and the network layer, right? So next thing is we have a five layer architecture. And also here also in this particular, sorry, for a support layer, there are also some security threats are there. Okay, denial of service attack, insider attacks. There are some other common threats will be there. Okay, and just for your information sake, I'm focusing on that particular thing. So if you don't know, don't worry about that. Just for your information. Okay. So next thing is we have a five layer architecture. So this particular five layer architecture is a good solution for some point of applications. Okay. So in that previous models what we discussed, there are some issues will be there. Okay. So this five layer architecture will try to solve that particular issues. Okay. So here nothing else, just remember the three layer architecture. Okay. So this particular five layer is a advanced version or an enhanced version or an extended version of improvised version of a three layer architecture. Okay. So here, if you carefully observe, we are adding two new layers to this particular thing. So one is the processing layer and another one is the business layer. Okay. Coming to the three layer, we have the perspection layer, network layer, that is nothing but the transport layer, and an application layer is there. And to in between that, we have a processing layer will be added, and also the business layer is added. So let us discuss about that particular two layers, which is nothing but the processing layer. Okay. So in this processing layer, in the from the beginning onwards, I am trying to explain you the same concept, right? We need to process that particular data. So in this particular layer, it gathers all the data from that particular prospection layer through some network. Okay, through some gateways are there. So all the information is stored and we need to analyze that particular data. It is one of the most important layer of an IoT because it makes all the decisions based on that particular analysis. Okay. Also, this application layer will interact with the user and will manage and to operate that particular IoT devices using this particular upon the data of this particular analyzed data. So this particular layer will be placed in between this uh, network layer and an application layer, nothing but the uh, transport layer. Okay. So here there are two major data processings will be happened at this particular layer. One is the data accumulation and data abstraction. So data accumulation is nothing but all the data gathered by the sensors of this particular IoT devices. No need to be used simultaneously. So what we do is we save that particular data in some other storage devices, or else we'll transfer that to the data lakes. Okay. And for or to some different databases for further use and for analysis. So the main goal of this particular processing stages, which is nothing but the data accumulation, is uh, to sort the gathered data and to store it in an effective manner. Okay, that is about the data accumulation. And the next one is the data abstraction. Okay, so this data abstraction, okay, is used for to get that helpful insights at this particular stage. Okay, so the IoT devices will get that particular insights. So the data will be reconciled or unified into some particular formats. So the gathered data will be used for some different other locations or different other applications. Okay, so that is the main agenda of this particular processing layer. Okay. Um, right. So we have this particular um, and also we have some attacks at this particular malware attacks will be there, and exhausting attacks will be there. Okay. On the top, we have a business layer is there. So that is a top layer. So all IoT communication models, or we need to send in general we need to send the information to the end users. So this business layer will be located above the application layer. So the business layer will ensure the to users which can use this particular IoT systems hassle free. For example, it makes the raw data into some meaningful insights in the form of a graphs or in form of a chats, so that the user can understand that particular data in an effective manner. Okay, so this layer is related to the decision making. So it might be interacts with the user or the stakeholders, etc., etc. Okay, so this is about the business layer. Nothing but this is an enhanced one. So we'll have a processing layer in between. We have on the top we have an what we say business layer. Okay, all right. So and the next one is the 7-layer architecture. So this is an important layer. So try to explain this layer. So with some introduction with a forum, which is nothing but an IoT world forum. So here I told you in the previous session, like this IoT is not standardized. Am I right? So for that particular sake, there a reference model will is introduced by Cisco, IBM, and Intel in this particular IoT world forum, which is nothing but this 7-layer. That is nothing but the 7-layer architecture. We call that as an IoT World Forum reference model. Okay. So these people which are from these different companies, okay, like Cisco, IBM, Intel, they come up with this particular 7-layer. Why? Because they want to standardize this particular reference model. Oh, sorry, this IoT. So to make that particular IoT as a standardized one, so they come up with this particular reference model. Okay. So let us discuss about this reference model. Okay, so here there are some characteristics are there which they introduced during this particular reference model. So the first one is nothing but which simplifies the data, nothing but it breaks down the complex systems, and each part should be understandable. And also they mentioned like this model should clarify any device or any IoT ecosystem should clarify. So it provides some additional information to identify the levels of an IoT to establish some common technology. And also they character this model characteristics is like to identify where the specific type of processing is optimized across different parts of a system. Okay, and one is the standardized, which one I mentioning it. So it provides a first step in enabling a vendors to create a IoT products that work with each other and at any point of time. And also the organizers, so it makes the IoT real and approachable instead of a simply a conception. Okay, so this is the characteristics. Let us discuss about this particular reference model. This is a 7 layer architecture, which we call it as a reference model. Okay, so here you can see here at the bottom you have an edge. Okay, so here edge is nothing but the devices or the sensors. Okay, on the top you can see there is a center is nothing but the cloud or a data center, etc. So these particular architecture or model reference model is divided into IoT and an IT. Okay, IT layer is nothing but the information technology. OT layer is nothing but an operational technology. Okay, so you can see the top three, the bottom three is having then OT, which is nothing but operational. The data will be in the operation mode, and on the top four will be like an IT, which is nothing but information technology. Okay, so we need to think one more thing like whether this cloud can handle this particular data, so we need to think in that particular prospect also. So filtering data is needed before storing that into the cloud platform. Effective analysis can be done whether before uploading to the data center. Okay, right. So here this is a reference model, okay, which is there. So I'll just give you an overview of this particular reference. Right, so the first is a perspection layer, which hosts that smart things or smart devices. On the top we have a connectivity or a transport layer, so which transfers the data from the physical layer to the cloud and vice versa via networks and gateways. On the top we have a processing layer will be there. Okay, okay, right. Let us discuss that in a clear manner before giving an overview. So let us discuss about the physical layer. That is the first layer. Okay, so we call that as a perspection layer. So as you all know, here in this particular layer, the data will be converted from analog signals to the digital signals, and also digital signals to the analog. This is the initial layer of this particular model, so which will interact with the end devices with nothing but with the real or the digital worlds. So there will be of different sizes and the forms. Okay, we have sensors will be there. Okay, and actuators will be there at this particular layer, and we have machines and devices are also there at this particular level. So it is important to remember that all these particular sensors and actuators, devices, everything falls under this particular category in this particular layer. Okay, and the next one is the connectivity layer. Okay, so in this particular layer, it enables the data transmission. So the second level is nothing but all the communications can be done across the devices or the network or the cloud services can be done at this particular level. So this connectivity is nothing but in between the physical layer and the cloud. Okay, and this connectivity can be done in two ways. Okay, nothing but how the data will be transferred from the device layer to the cloud layer. Here there are two ways are there, two key models are there. Okay, so one is directly using TCP and UDP IP stack, and the next one is via using some gateways. Okay, so that is what I'm explaining from the beginning. Okay, so using some, what we say, TCP and UDP protocol, the data from these particular devices, either might be an Arduino or whatever, the devices layer, the data will be transferred to this particular cloud platform using this particular protocol. Okay, and there we have some gateways are there, like hardware or software modules, which are used for the translations between the different protocols. Okay, so the data will be encrypted and also decrypted over this, and before the transferring that to the cloud platform. Okay, so here there are some. Uh, I just want to introduce some communication models. Okay, like communication things which are done between the devices and the cloud services. Okay, so like we have one Ethernet technology is there. Okay, and we have Wi-Fi technology is there. NFC is nothing but it is a safe data transferring between the devices with a range of 4 centimeters to 10 centimeters. Okay, that is what NFC is all about. And we have Bluetooth is also there. Okay, Bluetooth is also a connectivity process which we generally use. Okay, for short range communications. And here we are using a advanced one in that particular Bluetooth, which is a BLE, Bluetooth low energy, which uses low energy. And we have a low power wide area networks are also used for a specified IoT devices. So it provides a long range, what we say, connectivity for on a low power consumption. That's why we call it as a low power. So here the battery life of this will be more than a 10 plus years. Okay, so it will be generally used in smart cities or smart buildings or in a smart agriculture to monitor the fields, etc., etc. This type of things are used. Okay, and we have a Zigbee. This is one more alternative, like low power wireless networks. So with this particular Zigbee, we can handle up to 65,000 nodes. Okay, now nodes are nothing but devices. Okay, we can build a network with that particular things. Okay, so it was generally, we generally use this in home automation, and but it is also works in industries and in medical sites also. So there are cellular networks are also there, that what we are using, which we can offer the reliable data transfer, and we can use it in global coverage also. Generally, there are two cellular standard things are there. So long-term immersion for machines, and another one is the narrow band IoT things. So these are generally used for that transfer. And let me show you different network technologies in comparison between these connectivities. So generally, Ethernet is used for the wide and short range connections. Okay, and Wi-Fi, there are some pros and cons are also there. And also, I just showed you the popular use cases of that particular network technologies. So Wi-Fi is there, which is used for wireless and for short range. And NFC is used for wireless communications and also for ultra short ranges. Ultra short ranges, even the for less things. You can see this NFC is used for payment systems or smart homes. Okay, and Bluetooth is there, like wireless or short range, and low power wide area network is also there for wireless and long range, like smart cities or smart agriculture. We use this particular thing. And Zippy is used for wireless communication, but it is used for short range things. Okay, right. Sorry, short range things. And there are cellular networks are there, which is a wireless and for long range networks. Okay, for long range, whenever you are using drones for sending that videos, things. So here we use this particular cellular networks. Okay, so here, well, so let us discuss some most popular uh, things which we used in this IoT ecosystems. So to transfer this messaging protocols to across all the devices and everything. So one thing is the first protocol is a DDS. the data description services. So which we use directly with this IoT systems to connect with each other and to the applications which are having the addressing the requirements of these real-time systems. And we have one more thing called AMQT, the Advanced Messaging Queue Protocol. So which is used for to peer-to-peer data exchange between the servers. And we have one more thing, CoAP, Constrained Application Protocol. This is a software protocol which is designed for constrained devices. Okay, with a limited in memory and the power. Okay, and it is uses that HTTP for fewer resources. Okay, and that is what CoAP. So and one more thing is MQTT, a message queue telemetry transport. So it is a lightweight messaging protocol. Just a second, is there any glitch? Let me share it one more time. Now can you see my screen? Is it now okay? Is there any issue with my screen sharing? Now is it clear, guys? Just a second. Maybe there is an network issue. Just give me 1 second. Let me solve this. Okay, right, fine. I got it. Let me share it one more time. Now, please confirm me if my video screen is visible. Yeah, okay, right, right. Thank you. All right. So we are discussing about these particular protocols, CoAP and MQTT. Right. So in this particular IoT point of view, MQTT protocol is widely used. Okay. So in our coming sessions, we'll discuss about this MQTT because even AWS, Azure, or Google Cloud will are also following this MQTT protocol. So we will try to focus on this particular MQTT protocol in hands-on sessions in the coming sessions. But in general, this MQTT protocol is widely used in this IoT point of view. But there are some disadvantages there in this particular MQTT protocol. So to overcome that, we are shifting it to CoAP. Okay, so we are shifting it from MQTT to CoAP. Okay, so just remember that particular point, and uh, mm, I'll try to go to the second one, which is nothing but the edge computing. This is the third layer, which we call it as an fog computing also. Okay, right. So in this particular level, it is essential for any IoT system to meet the speed, security, scale requirements. Okay, like mobile data, etc., etc. Though we are generally all the devices, connected devices, generally they are using 4G standard, but we need to shift to the 5G time. So the idea behind this edge or an fog computing is to process and to store the information as early as close to the sources as possible. That is the main agenda of this particular layer. Okay, so this approach allows for analyzing or to transfer the high volume of real-time data to the edge nodes. So which will save the time and also the other resources. Or otherwise, what happened is we need to send all the data to that particular cloud platform, which results the system latency. Okay, to avoid all those particular things, what we do is we use this particular edge computing. So I'll just me show you this particular uh, slide for a better understanding. So this edge computing occurs on gateways, local servers, or other edge nodes. So which can stack at this particular network. Okay. So at this particular layer, the data will be evaluated to determine whether it needs to further processing at higher levels, or the formatting, or further processing, decoding, filtering, or redirecting to an additional destination, all of these things. So to sum up all these things, what is happening is the data is transferring, maybe sometimes we can directly transfer, like directly we can transfer the data to the data center. Okay, and also we use some sources, nothing but the edge nodes, like that. Simply remember that. So these end nodes are nothing but just like a gateways. Okay, so here there is a machine, factories are there, some data servers are there, some mobile data devices are there. So the data is transferring to the particular edge node, so the data will be stored here. So there will be some processing. Okay, and then shifted to some other edge node. There few more what we say processing can be happened. Okay, and then it shifted to the uh, what we say data centers. Okay, like that the data will be transferred and then shifted to the data center in some cases. Okay, before direct, I mean, like we not directly pushing the data to their uh, what we say cloud platforms. Okay, fine. Right, fine. So this is about that particular edge devices. Okay. So let me tell you one more example for a better understanding. Like say suppose okay, weather monitoring is there. Okay. So whenever you come across for any things, you come across this particular weather monitoring to know whether what is the temperature of that particular. So here what is happening is uh, say suppose when how this data is calculated, how this data is collected. Okay, so you can see like there will be some temperature sensors will be deployed at a different places. Say suppose at Hyderabad we used to have that particular temperature sensors. In Warangal we have, in Bangalore we have, in Vizag we have, like that at different places we have that particular data. Now can we directly push all these sensors data, temperatures data to the cloud platform? No. Okay. Because some due to some reasons we can't transfer the data directly to the cloud platform. So what we do is we have this particular edge nodes. We use this particular edge nodes. Okay. So these edge nodes is used to collect the data from that particular devices. Okay. And say suppose sub Hyderabad is there. So there are different zones are there. Okay, all the zones will be collected. The data will be collected in that particular zones through an edge node, and that edge node will transfer that data to the main hub or to then another edge node. From that particular edge node, the data will be transferred to the cloud platform. So like that, the data will be consolidated or filtered from edge node to the edge node. Okay, and then finally the data will be shifted to the cloud platform. So if you want to know the clearly, if you want to go in that particular weather app, you can't go and search for a one particular area. If you want the temperature, it gives a temperature of Hyderabad, but it won't gives a temperature of the so and so colony. Okay, but in that particular cases we use that particular sensors in that particular colony, but the data can't be visualized for us. Okay, so that is the main intention of this particular edge computing. Got it? Okay, so this is the main things. Then so here if you carefully remember, chief, carefully observe over here. So from these particular three layers, the data is in motion. Okay, the data is transferring from sensors to the connectivity, using connectivity and to the edge computing, and then upon hitting this next level, the data will be in rest. Okay, now the data is available for the use by the consumer application. So you can see here the data will be in rest position. Okay, so here the next layer is about the data accumulation. Okay, right. So here a data accumulation stage. So here the real time data will be captured here. So how they are captured, there are some other means are there, like APIs will come into the picture, and that push there are some requirements will be there. So this data accumulation component stage nothing but works like an transit hub between the event based data and the query based data. Okay, so this particular stage is very important. So here the raw data will be converted into some useful insights. It will store that particular data in the databases, etc., etc. And upon next we have abstraction if stage will be there. That is the next layer. So here the data preparation is finalized. Here the consumer applications will be there. They generate some insights based on some particular parameters. They use that ERPs, CRM systems. They reconcile the multiple data formats. They aggregate the data in one particular place. So respect to the location, the data will be visualized. All these things can be happened in this particular layer. Nothing but the processing can be happened in this particular layer. So similarly, the data collected from data will be shifted to the application layer from this particular layer only. Okay, so on the top we having an application layer. So, device monitoring, controlling softwares will be deployed over here. There are some interactions will be there. So, business intelligence services will be there, and there are some analytical solutions can be used over here. What we say, machine learning models will be there. So, data mining will come over here. Advanced analytics will be done over here. Data visualizations can be done here. All these business requirements can be done in this particular layer. Okay, and after that we have a collaborate business layer, which is nothing but the collaboration and the processor. And here, as we already discussed, this problem solving solutions will be there. Stakeholders will take over the charge of this particular data. Okay, all that can be done in this particular layer. Okay, so this is about the uh, uh, architecture which is prominently used, which is given by this IoT World Forum, okay, which were by Cisco, IBM, and some other company. Okay, fine. So this is an architecture of this. So this is a system topology. So we have end devices are there, gateways, networks, etc., etc. So let me move. And one more main important thing is about the security. Okay, so they are mainly this forum is mainly concentrating on this particular security. Okay, so this security is very important. So if there is no security, then it is a very what we say waste of implementing all our ecosystem. So security is very important. So there is a separate topic will be there, broader topic like IoT security. That is very important without breaching that. So this particular security, we implement this particular security in each and every layer. In each and every layer we implement this particular security. Okay, so upon the basic features we consolidated that into a few things. Okay, so one is the device security. Okay, so all our modern manufacturers of this particular IoT devices will include these particular security features in their hardware and then firmware. Okay, so there are having some models will be there, TPM, embedded TPM trusted platform module. So will be there. So that main thing is not to get you confused. So the device should be more secure. That is the only thing. The bottom line is like the devices which we are using for this particular IoT system, ecosystem, that devices should be more secure. No one should hack that. No one should come and stole it, or no one should alter the data. For that, we need this particular device security. And next one is the connection security. Okay, connectivity. So through what means we are connecting that data to the cloud platform, how we are transferring the data. So for that, we have different protocols: MQTT protocol, AMQT protocol, TDS protocol, so which uses some standard transport layer security. So sending that data to the cloud platform is also one of the most important thing. And the next one is cloud security. So even though if we don't have uh, cloud security, is to waste of transferring the data to the cloud, right? So there are some other means are there. You can store. If suppose if I created an infrastructure, if I established an infrastructure, and if I ask you to transfer your data to my infrastructure, to my cloud basis, you won't transfer because you don't have trust on me. Even though you know me, but you won't trust me whether your data is safely in my infrastructure, in my cloud places are there, right? So that's why there are some companies are there like AWS, Microsoft, Cisco. So they are large providers of this particular cloud with some security. There will be end-to-end data encryption. That's why whenever you see that in WhatsApp, you can come across this particular end-to-end encryption. Why? What is happening? Our data is securely stored or securely transferred. That is what this particular cloud security or end-to-end security talks about. Got it? And this is about the security things. So for that, we are using at different points of level. So we are using different technologies, other mediums to provide this particular security. Okay, so I hope you know few of them over here, like Mongo had DB to store that particular data, like TCP, UDP, HTTP to transfer the data, MQTT. So there are communication models are there. Okay, these are the different things. Just for your awareness, I just showed you this, and these are the threats issues regarding the security, the percentages. Mostly it affects on medical industries. Patient monitoring medical devices are in more threats rather than the other stuff. And these are the top IoT security threats. Okay. Malware threats are there, exploits threats will be there, user practice threats are there. Okay. So these are things. So for the best practice for this particular IoT security, first of all, we need to identify all the managed and unmanaged devices with the context. And we need to accurately access our data, and vulnerability are there. So we need to check in that particular uh, 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 things. Okay. And we have some trust policies will be there which we need to enforce that. And we need to know about that particular threats, and we need to rapidly detect and that particular threats. So that will be the main practices. So this is the reference model. Right, let me skip this. And here, this is about the first. So to uh, this is a solution to avoid all those things. We are using other technologies like AI, big data, uh, to safeguard or to save our data. Okay. So this is about this particular architecture and the security things. So right now we are not focusing on that particular IoT security more. So that is another different topic. So so I'm constraining it till here. Okay. So if you have any queries till now, you can ask me in the chat box so that I'll explain you in detail. Right, fine. Data abstraction and data accumulation. So both falls under the same processing layer. Okay, like data abstraction is like it focus mainly on the necessary information to the user. Okay, nothing but it is say suppose um let's say suppose a TV is there. Okay, this particular TV will have some complex things are there inside. Okay, but the user will have only a simple buttons. Using that particular simple buttons, he are going to control that. So this particular a data abstraction is lighting, but it simplifies the complex systems into an easy understandable format uh, to that particular user. Okay, so data accumulation is like it accumulate the what the user needs. Okay, what the user wants. Okay, so for that we need to analyze that particular data using some data analysis, decision makings. Okay, so that can be done in that particular accumulations. Okay, so abstraction will give you the easy complex data will be transferred into a meaningful user understandable language, and accumulation will give you the insights of that particular data. Okay, any other queries? If you have any other queries you can ask, guys. So right, so that's it for today, guys. So in next class we'll discuss some other topics. Mostly all the topics are completed. So we'll try to discuss some other things, and then we'll try to go for some hardware sessions. So if you are okay with that, you can bring your laptops. So we'll do some work on that. So we'll see where I'd update you in the next class. Okay. So that's it for today, guys. If you have any queries, you can ask me. I'll try to answer that particular queries. So I didn't get your question, Dakshina Murthy garu. So if you don't have any queries, you can leave the meeting, guys. Uh, so we don't have an access to talk, sir. You can please type in that chat box. So right, someone asked me a question like a freezer process. Let's assume we have like 1 lakh freezer process located across the nation. My question is how to bring IoT into this freezer box which stores ice creams and other food items. So here, if you want to bring that is um like say suppose if the freezer process are there, are you if you are storing some ice creams or other food items, you need to know the temperature of that particular boxes. Okay, say suppose if you are running any ice cream stores at different locations, like suppose Amul ice creams or some Hudson ice cream, say suppose you need to monitor whether that particular store fridges are maintaining in a proper temperature or not. So what you do is you integrate this IoT in that particular freezer process, in that particular stores. Nothing but you install some temperature sensor to that particular freezers. The data will be uploaded to the cloud platform, so that the owner or the manager will know whether that particular uh, the temperature is maintaining or not. One concept. And another one is, even you know whether that particular door of that particular freezer is opened or closed, how many times you are that particular door is opening or closing. Okay, because all the ice creams or the seafoods or the frozen foods need to maintain some particular temperature. Okay, if you keep on opening or closing that particular door, the temperature will be lost. If the door is not properly closed, then the power consumption will be more on that particular what we say fridges. And so if the power consumption is more, okay, again that will cost us more, right? So to avoid all the such situations, what we do is we try to integrate this particular IoT into that particular, so that you'll have a record how many times you opened. Then you can warn that particular store manager that don't open that many times, don't open the fridge door that many times. Okay, so that you can warn him. If you open that many times, that freezer temperature will be less, and that items inside that will be damaged. Okay, so yes, key parameters is to monitor that particular machine. Okay, and also you can get some insights of that particular, okay, this many temperature is maintaining, that's why your product is in good conditions. You can give some insights to that particular, you can monitor that particular fridges, are they working properly or not, so that you can monitor it. So here you can, you only saying that there are like 1 lakh freezers are there. So how you say, suppose some one particular freezer got damaged, it is not maintaining proper temperature, even though every all the measures are followed, then immediately you'll get a notification to your mobile phone or to a mail saying that at that particular location and that particular freezer is not working, try to replace it, try to modify it. So that immediately the technician will go over there and repair that particular freezer, or else if it is not in a good condition, then he immediately replaces that with a new one, so that the products or items in that particular situation will be, that store will be in a good condition. Okay, in same sub, we come across different situations. That particular shop is not good because they won't maintain that particular temperature. The ice creams are very the coolness, the temperature is very low. That why that ice cream is not good. Maybe they eat that particular ice cream at different location with good temperature, they liked it, they want that in this particular different location, but they are not satisfied. Like that you can do some insights on that particular situations. I hope you got that particular answer. Parking lots can be implemented, because say suppose there is a mall is there. Okay, so if you are moving to that particular mall, you will set a maps in your mobile. Okay, you are going to some suppose that particular mall, Nexus Mall or Lulu Mall. Okay, so what happened? You, if you are going there, so you need to know whether that, so if you are going in a peak moment, like say suppose on Saturday. Okay, you want to know whether there is any parking slot is available in that particular mall or not. If you don't know what happens, you'll go to that particular mall. The security guard will say that there is no slot. Is try to go away and park in some other place. Okay, that will affect your time. Okay, you don't know where to park, etc., etc. But if you know, like there is a parking slots are available or not before you reach that particular location, it will be helpful for you, right? So how to know that particular parking slots? So in that particular slots we'll try to implement these particular IoT solutions. Okay, then we'll get the real time information to the user. Okay, right, this particular mall doesn't have the parking slot, so I need to search for an alternate way to park my car, to park my bike. So that is an helpful for an user. So that is how we implement that IoT in that particular situations. Any other queries, guys? I hope all your queries are answered. Uh, right. If you have any queries, you can ask in our next sessions. Okay, we'll try to solve it. So once my intention is like if you have the strong fundamentals, then it is easy for you to develop any IoT product. Okay, fine then. So thank you guys. Thank you for attending. See you tomorrow and have a nice day. See you tomorrow at sharp 9 o'clock. And thank you guys.
Yes, we will mark that in. So if not, I shared that link. So please mark and we'll see you on tomorrow at same time. Thank you guys.